Hey everyone, Mr. Anderson here, and today we're going to talk about section 6.1.3 from our CPM Common Core Algebra textbook, and we're going to look at boundaries on our predictions. The goal of statistical analyses, at least as far as we're using it in this course, is going to be to make a prediction, and our predictions have limits. Okay, and so we're going to talk about ways that we can do that, what it might look like if it's done well, and what it might look like if we maybe want to or need to toss it out. And we're going to use problem 6-22 here to start. And I've got some answers pre-populated here. We're going to talk about them for the purposes of just getting this moving and getting you thinking about some things. In 1997, an anthropologist, and you might have a question about what an anthropologist is, and an anthropologist is a scientist who studies humans' habits and behaviors throughout history, like past societies. So an anthropologist might be studying the Greeks or the Romans or the sub-Saharan Africans or the the Japanese during a certain dynasty that existed in the 13th century or something like that. And they might be using data to make some predictions about that. And that's what our anthropologist is going to do in this problem. As part of an analysis of the specimen of an early humanoid this person found in Europe, the anthropologist needed to determine the approximate height. So we know right away this person wants to make a prediction about the height of the humanoid skeletal remains. Okay? The thing that they found was they found an ulna bone, and that's your forearm. They found an ulna bone that measures 26.4 centimeters in length, and we're going to go ahead and figure out how we can make a prediction based on that alone, how we can make a prediction of how tall this skeleton was, because this anthropologist has limited information because of the degraded remains or whatever, for whatever, maybe there's some missing pieces or something like that. So what we're going to do is we're going to get started talking about some of these things that I've got kind of laid out here, and you guys can be thinking of these things, and my answers are not the only answers here. Yours are probably well worth the time and energy spent thinking of them as well. So here we go. What information should we gather to answer this question? Well, if you're watching this, you're probably in a distance setting, and if you were in a classroom setting, it might be easier to gather this information, but it sure would be nice if we knew the relationship between everybody's ulna and their height. Okay? And that's collectible data. And if we had that classroom setting, we could do this. More data for our purposes is going to be better data. Okay? What process would you use to gather this info? And I would say, like, if we're in an in-person class, we could have everyone take and report their own measurements. Pretty easy if I've got a measuring stick to measure my ulna. We just have to agree upon it. Am I going elbow to wrist? Where on the wrist? And then what constitutes measuring my height? Am I doing it with my shoes on, with my shoes off? Am I doing it back against the wall? We just want to make sure we're all doing it the same way. All right. And then what statistical information could we give back to this anthropologist? Well, if I'm the anthropologist, and I'm not, but if I were, it would be nice if I had a model given back to me. If I've hired some statisticians to do something like this for me, I'd want a product back. I want a model that I can use to make this prediction. And that's what we're going to try to do today. All right, and I've got a problem here, and if like I said, we're in an in-person setting, we would have the ability to collect this data. It would take some time, but it's worth it, okay? And for the sake of this video, I've given you guys some data, 1, 2, 3, 4, 5, 6, 7, 8. There are 8 measurements here, 8 forearm lengths along with the associated height of that individual, and that is the data that I'm going to use. Now, I made a comment here about how data in table form, sure, it's fine, okay? But if you really want to check out data and work with data, it is definitely very, very helpful to visualize it. So that's going to be my next step. I did this ahead of time using www.desmos.com, and I went ahead and I graphed our data. Now, some things that I'm seeing, and I screen grabbed from Desmos. Some things I'm seeing, okay, over here on this side is my data, but some things I'm seeing is I'm seeing a positive trend in that data. Okay, I'm seeing a positive trend. That data is trending upwards from left to right. That tells me there's a positive association, and that makes sense to me because as a person's forearm gets longer, that person is generally taller. Okay, that makes sense because taller people have longer arms, right? All right, okay. What else am I seeing? Well, my data, maybe due to measurements like that, not super tight, not super strong, but it might be, right? We'll do some thinking about that in a second. And then the other thing that I would probably say about my data is it does seem, now I've cut my axes off here, but it does seem with my data that it does appear to be linear. All right, you can see I go from 220 to 300, and I go from I go from 21 to 30, sorry, and then I go from 120 to 200 on that y-axis. So it's a fairly linear model. I'm confident that we're a positive, moderately strong linear model there, and doing some of the things that we're about to do is going to be perfectly acceptable. Okay. I want to go ahead here and I want to drum up that linear model, and I'm going to use a process that you've maybe seen in your science class. If you watched some of these earlier videos, you've definitely seen this, and this model is going to go like this. I'm just going to grab like a red, and I'm going to thicken it up a little bit so it stands out here for our video. And my goal when modeling our data with a regression model, or the model that I want to hand back to this anthropologist, is going to be to try to make it match the trend of my data and split my data. Now I've got 8 measurements, and that means I probably want to get about 4 above and 4 below. Now it may not be perfect, but for my sake right here, I can kind of do something like that, and that's going to work. That's going to work out really gosh darn well, in fact. Okay, and then the next thing, and this might be a bit of a review for us, because I want to write the equation of this line, I want to go ahead and I want to pick 2 points that are on my line and write this equation. And this, I'm going to go quickly through this because this is an old skill. So this right here is the point 27, and it looks like 170. So I'm just going to mark that up, 27 and 170. I'm just going to find one more that really fits on a nice gridded point. Oh, this is going to be good. That'll work. Let's see, 21.25. And that's going to be what, 140, 145, 145. Okay, so my math might get a little bit sticky, but it's not going to be too bad. And I'm going to write this equation. First thing I got to do is I got to find the slope. The slope is going to be y2 minus y1 over x2 minus x1. Now, I'm going to pause this video, and you're going to pause your video, and you're going to work it out. And we're going to come back together in just a second, and we're going to check it. All right, you can see how I did there. I went ahead and did the subtraction up top, got 25. The subtraction on the bottom, got 5.75, and I divided, I got about 4.35. So that's going to be my slope. Now over here in blue, I've got a little bit of a hint for how you can go ahead and find that y-intercept. All right, one more time, I'm going to pause the video, ask you to do the same thing. Try to find that y-intercept, please. All right, like I said, over here in blue, I've got this thing worked out now. I went ahead and I took my slope-intercept form. I plugged in my slope. I plugged in a known point. That known point was 27,170, and I just did some solving, and I got 52.55. Now, as I mentioned, we do want to be able to hand back a model to this anthropologist. I used X and Y in my blue writing up there, but my anthropologist maybe wants this model to be specific to this situation. So down here I've got a scenario where I use H for height and F for the forearm length, and we can write this, and I'll make this stick out. Let's use purple. Why not? All right, I can go ahead here and say the predicted height is equal to that intercept. This is how it's often done in statistics, plus the slope times that observed or measured forearm length. Okay, we often write that intercept first, plus the slope times or multiplied by the independent variable. Okay, and the slope in this particular case of the 4.35 means that for every additional centimeter in forearm length, the human is predicted to be an additional, this is an interpretation of my slope, an additional 4.35 centimeters taller. The y-intercept is 52.55. And this means that for a forearm length of 0 centimeters, right, the human is expected to be 52.55 centimeters tall. The y-intercept, though, in this particular case, and if you want, go back to my graph and you can see this, doesn't make a ton of sense because it has been extrapolated far too far from the actual data. It's a measurement outside of our actual data set, so we don't want to be using something like that for the purposes of the for the purposes of prediction, right? If we are going to predict, we want to be able to do that within our known data values. Okay, moving on to the next question. We're going to try to do this quick. I'm going to do some pausing, and I'm going to ask you guys to do the same thing. Moving on to 6-23 here. The height you found for the humanoid is a prediction. Remember that. The actual height of an early humanoid was probably a little shorter or a little taller. In this problem, we're going to investigate how we can report a range of values. So here we go. Look at the data you collected and the line that models the data. Identify the point that is farthest from the line that you drew. Now here's what I'm going to go ahead and do. I'm going to pause this for a second. I'm going to make my line reappear. All right, so there we go. I've got that pasted back in there, and we're asked to identify the point that is farthest from the line that we drew. Here's the one that I think is the farthest. They asked me to calculate the residual. Well, the residual, remember, from prior learning is the predicted value minus the actual value. And the predicted value, using my model, and hopefully you guys can see my calculator here, oops, trying to show it there, is 156.95. I just took the 52.55 plus the 4.35 times 24, and I got the 156.95. And then the actual, you can see I kind of highlighted it in the table over here, is 175. So we're going to go ahead and do this subtraction, and my residual is negative 18.05. Okay, now here's the point of this, right? We're going to try to calculate this range of values. So in part B down here, they say in a different color, draw a dashed line that goes through the maximum residual point and is parallel to your model. Now I've got to do some estimating here, but I think I'm going to be able to get reasonably close there with that orange line. Okay, then they say try to do the exact same thing, but now down here on the other side. And this is where I got to get a little crafty. I'm trying to make these things approximately the same height or the same distance from the red line. And I know that's not perfect, but you're going to forgive me. And they did say to make it dashed. I just made it orange. Okay? But ladies and gents, what this is going to allow me to do is develop a upper and lower bound to create a range. And they give me a specific task. They say, hey, predict the humanoid height with a forearm length of 26.4. Well, here's my 26.4 measurement right here, 26.4, just shy of 26.5. All right. And the humanoid height we're going to have for a range here is going to be, what would you say that is? I got to do some estimating here. What's that going to be? About 147 to 187. 147 to 187. 140, I'm going to write this down, 147 centimeters to 187 centimeters. All right, and when we talk about this, that is a 40 centimeter difference. And if I take 40 centimeters and divide it by 2.54, that's about a 16-inch difference. So here's where I'm really questioning how worthwhile my model is. And it's kind of one of these things that happens with predictions, right? We don't always have the best model. And as we move forward, we're going to be discussing how we can be 100% positive a linear model might be the best model. Ladies and gents, I have a tiny bit of review preview for you here right at the end. Thanks for watching. Have a wonderful day.